presentation? Yeah. Over there. Ooh, yeah. That good? Okay. Yeah. Okay. So a little bit about me. So who I am. Like I said, I'm Sven, or in the internet I usually go by the name of Shogoki, or my Twitter handle is dshogoki. My background is I probably kind of work in IT, computer science, like all my life. Like I was like for a long time was in IT infrastructure and architecture, also looking into security and hardening of that. Then have like a couple of years experience in full stack development, also doing DevSecOps in a big enterprise company. And then like the last 3 years I'm in Web3 security, doing security research, did like smart contract auditing in the beginning, doing audit contests, and since almost 2 years I'm working with Sherlock, first as security specialist and right now back to being a developer at Sherlock, working at Sherlock AI. And OpSec is just a topic where I'm like personally a bit like passionate about because I think we are all security people and sometimes we forget about like the personal and the operational security around it. So if you guys want, we can do like a little bit of the beginning poll on, I have like a Slido up here, so you can either go to slido.com or scan the QR code and attend the poll to say how confident you currently feel about your personal OPSEC. Get it up. Starting it. See if we get anybody in. Okay. Yeah. I need to switch back to the other presentation. Oh, yeah. Sorry. Where is it gone? Okay. See, wait a moment, if we get people coming in, I wanted to switch back to the other presentation though, which I lost. Let's see. Yeah, there. That's right. Yeah. Okay. Oh yeah, I think I need to show the results. There you go. Yeah. Okay, so yeah, that's pretty good. So everyone feels a little bit somewhat confident. Then I guess let's go into it. So I was showing this before. I think I might have like switched to the other slide too early. But did anyone scan this QR code and ended up at a like you could have been porn website? Yeah. So that's like one point I wanted to talk about is if you scan QR codes at places, you should always verify like the URL. So I was giving you this. It says slido.com. You could have just went there, and then there's like a short URL in the QR code. It could be anything basically. It could be a fake Slido website or whatever, right? So this is one thing. we basically have to be always aware what we're doing and about our surroundings. So always check if you scan QR codes, if it's actually the URL you want to go to, or better, if you know the URL, just go to the URL yourself. So why does personal OpSec matter? Like, I think all of us here security people, I already said it, and there's like kind of an irony to it. So some of us are security researchers. We secure like $1 million protocols, checking their code, but then on the other side, we use like the same browser for looking at Twitter than like we use for signing crypto transactions. So there's like a kind of a gap between, on the one hand, we all know there's like security risks and we know how to break things, but then there's sometimes not like 100% awareness of thinking about what we're doing in our personal life and day-to-day life. So, so it's yeah, thinking about separating things and just being aware of like that. We are all like kind of targets. Like crypto is like a specifically targeted community for attacks, and this is yeah. So if we talk about OpSec or security, we can always think about it in multiple layers. Like there's physical security, which is things we can do easily. Then we talk about devices, networks, and then application, and also behavioral security. I also have like a difference we can see. Like there's general things which like valid for everything, like in Web2, in general life, and then there's like Web3 specific things. Like a very easy thing is, like you're all at a conference right now, you're working here. Do you know who the guy next to you is? Do you know if you can see what you're doing on your screen? Easy thing, you just have to pay like $10 to get like a small privacy filter, which is like this, and nobody can see from the side what you're doing. Like easy things like this can secure like what you're doing in a exponential way, I'd say. Then, of course, using hardware wallets for crypto is super important. Then, talking about devices and just having different profiles. Like, you have your browser, like every modern browser supports doing profiles, so just like, we can separate using that. If you're a signer on a multisig, you should probably like think about having dedicated devices, like specific hardware devices, like a dedicated computer to sign these multisig. So it's things like this. On the network side, thinking about VPNs and using secure DNS settings. On the Web3 specific side, thinking about the RPC. So it's like a central point of failure. Also, they can see from where you interact. They get your IP address, etc., etc. On the application side, password managers, two-factor authentication, really important. And then we have things like on the Web3 side, like transaction simulation and approval revoke tools. Yeah, we'll talk about that later. And then, most important, like on the behavioral side, is like verify, don't trust. So never trust what you see. Same thing with the QR code we had. You should verify what's going on there. And then trust the device, not the UI. It's more like for if you're using hardware wallets, then you can see the transaction data on the screen, but you should always trust the device more than the UI. So in that case, like the hardware wallet. Yeah, so I think I already talked a little bit about it. Like in general, like for OpSec, in terms of authentication, you should always use two-factor authentication on every service that supports it. And then there's like different layers of doing that. In the past, it was like text messages, like SMS or email, which were used often, but these are considered as like not secure anymore because there's a lot of attacks, like SIM swap attacks, and your email can also get compromised pretty easy. So ideally, you should use a hardware key, like a Chubi key, or if not possible, then you should use like an authentication app. Like there's like famous ones like Authy, and of course like Google Authenticator, which you can use for that. And then, yeah, enable it on every service, be it email, make GitHub if you're a developer, exchanges, your socials, whatever. Yeah, then about physical security. Already talked about the privacy filter, really cool thing. Then, if you're not on your computer, always lock it. No matter if you think you're in a trusted environment, you should always lock it if you're not there. Yeah, camera covers is also a nice thing. You can buy like a $1 cover to pop up upon your camera to prevent any unauthorized access there. And if you travel to risky locations, you probably should bring like burner devices. Yeah, I think you all got like this little handbook like when you got here. It's like, I just had a brief look at it. It's pretty good, like in terms specifically for traveling. So yeah, appreciate they hand these out here. Yeah, next thing is, again, the digital hygiene. Like, I talked about browser profiles, so you should ideally have like a different profile for work and personal at most, and then have another one for crypto or DeFi, or if you're doing specific research stuff. Like I said, if you're a signer, you should not use the same device for signing on multisigs as like what's your daily driver. And obviously, you should keep your devices up to date, install security updates and things. Another thing is like out-of-band verification. Like if you get like a message from someone you potentially trust, and if it's like a critical topic, you should probably like verify if it's really them. Like message them on another channel or call them, ideally, if that's possible. Yeah. Yeah, about the threat landscape. Like, we talk a lot about crypto hacks and exploits and stuff, but I think that the main risk still is actually operational security failures. Where, like, main thing, 70% of individual losses of individual users is still phishing attacks, social engineering, and also a little bit with malicious approvals. And like, we see recently what pops up a lot is like these fake job offers, or they want to get you on a call, or like if you say, if you're a security researcher, they reach out to you, yeah, I need an audit, and then they have a special meeting software or something. They want you to install something on your computer, so that's pretty important to be aware here. And then, of course, we had beginning of the year the Bybit hack, which is pretty interesting because it was like basically 2 different operational security mistakes that made this possible. Yeah, talking about that. So what happened with Bybit is we had on the Safe Wallet, which is the provider of the front end for the multisig Safe Wallet, there was a dev that was compromised via a malicious PDF, which led to a key being leaked, which allowed the attackers to deploy like a malicious JavaScript on the front end of the Safe Wallet. And then, so that was the first operational security break here, so that the dev got compromised by a PDF. The second one was that the signers didn't verify on the device. They trusted the UI, which is obviously was showing another value than like was shown on the hardware wallet. And then multiple signers signed this transaction, which led to the loss that we all know about. Yeah, so awareness building is therefore a pretty important part. I'm going to get a little bit quicker about these slides because I think hopefully everyone knows about it. So phishing, always check like websites, like little spelling mistakes like this, or like mimicking tools. Take care for like compromised social accounts, like if somebody, like an account suddenly posts something and usually there's like some urgency, like claim now to get like these tokens from the airdrop or whatever, then it's like a critical sign, let's say, to say. Then obviously social engineering, they do a lot of like these job offer things, like I said, where they try to get send you like a PDF which is fake, or like a fake meeting tool quite often happens, or like an assessment tool could be the case. Basically, they want to run code on your device, and you should just be aware to never do that. And if you're not sure, then we have like sandboxing possibilities to run these tools without doing any major harm. Yeah, then there's like a couple of myths around operational security, like why should they target me? I'm not important. But like if you have a public profile on any social or something, you're a potential target, always. So a hardware wallet is, yeah, I'm using a hardware wallet, so I'm safe. So, I mean, at the end, it's still the user that decides to sign the transaction or not. So if you don't verify the transaction and you sign a bad transaction, it can happen with a hardware wallet, as we've seen with Bybit, obviously. Yeah, maybe you think I'm good, I can spot phishing, but sometimes, yeah, it happens to everyone at some point. If they also get better and better. It almost happened to me at one point, so we just need to be always aware. So I think it's easy to lose track of. Like we all have like a busy life, a lot of things going on, like especially in Web3, like everything evolves so fast, and then it's easy to lose track of things, and then, oh yeah, I need to quickly do this, and then there's one moment you're not aware, and then they got you, right? And yeah, last but not least, like VPN protects me. So VPN can protect you in terms of it hides your IP address, but it's also critical to think about if you use a public VPN provider, you're just shifting the trust from the network you're in right now to that VPN provider. So it's a matter of question if you want to do that, if you trust this provider more than your local network. Yeah, so what can we do to, in terms of tools, like a little bit to get more hands-on maybe, what can we do to up our OpSec game here? So we have like different categories, as we already said, like we can talk about isolation, which is Docker is like a good start. Then there's things like dedicated hardware and even like more advanced things like QubesOS, which is like an operating system, which basically starts a new virtual machine on the device for every process that you're doing. Like you would have like a own virtual machine for your day-to-day browsing, another virtual machine for signing, and so on and so on. So, and approval management, if you have like token approvals, like sadly, still, if you're a DeFi user, you have like a lot of DeFi applications that by default will still request like an unlimited token approval instead of the amount that you entered. So therefore, revoke.cache is like a really good web tool to check all these approvals and to revoke them eventually. Then document safety, pretty good. Like I said, the safe dev, he was compromised by a PDF. There's a tool called DangerZone, I will show in a second, which allows us to securely open like untrusted documents. And yeah, obviously transaction decoding, if we want to sign transactions, we should always know what's going on. And if it's like not in clear text, then we have to know how we can decode a transaction. Last but not least, multisig security is, we're talking a lot about multisigs for organizations, which is obviously important, but I want to raise a point that it's also a valid thing to do as an individual. You can use a multisig, you just use multiple hardware wallets and maybe one hot wallet in a 2 or 3 multisig, and you increase your security by a lot by that. Yeah, so talking about revoke.cache, I think it's pretty well known. So maybe hands up who does not know revoke.cache. Oh, it's a lot actually. So revoke.cache is a tool which lets you check your wallet address for token approvals. Let me open it up for you. So just open up like a random address. So you can connect your wallet in read-only mode, but you don't even have to. You can just enter the address, and then it will list you all the token approvals you have. You see, on this address, there's like a bunch of unlimited token approvals, and you see which contract is approved for it and when it was last updated. And then if you connect your wallet, you can also directly revoke these approvals and make sure you're safe. Yeah, there's also like the nice feature, you see like the value that is at risk. So, which means there's an approval for this token here now, an unlimited one, but I don't hold any of these tokens in these wallets, so there's technically nothing at risk. Still, it's a good idea probably to revoke these permissions. This is weird. Okay. Oh yeah. Yeah. Talking about isolation techniques. Yeah, the most basic thing I think we can do is Docker containers. So I would recommend, if you don't already have it, install Docker on your device, and then, especially like if you're, for example, a security researcher and you run like code from a customer, like from a client, you should run it inside an isolated container, because even like running Foundry tests or something can potentially be malicious code. It's at the end of the day code running on your machine. You should always run it in like an isolated environment, like a Docker container. this was like my day-to-day job at Sherlock, like the last 18 months, I think. I was running a lot of foreign code-based tests, and I always ran it in a container to make sure there's nothing that can compromise us. Then, if you want, you can use virtual machines, of course, like with Parallels or like VirtualBox, to use virtual machines as like an even higher isolation. Then we talked about dedicated devices. Like if you have like a high-value multisigs, you want to have like a dedicated device just for signing, and then you use it only for that. It can be a cheap like $200 notebook. Just install like a secure OS, like a Tails OS or something on it, and then you're good to go. And then, yeah, I also wanted to mention QubesOS because that's a really nice project, which I already said. It creates a VM for every process that you start. Yeah. Now, DangerZone, I think I already mentioned it. The website for that is dangerzone.rocks. What it does is, you need to have Docker to use it, but it's easy to install Docker. Even if you don't know how Docker works in the hood, you can just install it and then use DangerZone still. And then if you install DangerZone, and then you can open a PDF with it, which is what I want to show. Yeah. So basically, if you receive like unsafe files like PDFs or PowerPoint presentations, so this is just my presentation here now, then you can open it with DangerZone. And okay, yeah. What happens is that you convert it to a safe version of the document. We do that because it takes a moment. And then what happens now is it spins up a Docker container, and it reads the PDF, and then basically takes a screenshot and uses OCR to create like a PDF that has the same content, but only the visual content. So if there's like malicious code injected in the PDF, you don't get like the malicious code at the end. And it works the same for like PowerPoint presentations or Office documents, but you will get a PDF out of it, not like the original document format. So that's like a little bit of a bummer, but if you just want to read it, it is a really good way to do that. Okay, now it finished, and it was opening on my other screen. So you see it's just the PDF, it looks the same, but yeah, potentially unsecure code is not in there. So this is like a no-brainer for me. Just if you receive PDFs or documents from like customers or other persons that you only semi-trust, then you should do this, and you're way safer already. Yeah, another thing, like we talked about, transaction decoding. So if you have a transaction hash in your wallet or maybe in Safe, then you can easily decode it with Cast, which is like a tool from Foundry. You just use the 4-byte decode command, and you see basically the function signature and also the parameters that were set. So it's an easy thing on the command line. I think maybe I can also show how that might look like. Is that big enough? So, yeah. It's probably not like a good one. Try this one. Yeah, this one easy one. So this was like the transaction hash. I just copied like 4BD is the shorthand for 4-byte decode. And then we see this was like a transfer transaction, and this is the address it goes to, and this is the amount, like pretty easy. Yeah, then we can talk about RPC privacy a little bit. If you are concerned about your privacy on-chain, then you probably want some privacy in terms you're connecting to the RPC, because your RPC is the entry point to the chain. So they will see your IP address and potentially where you are right now. You can use a VPN if you're concerned about that. You can channel it via the Tor network as well. Or if you can use private RPC providers you pay for. I mean, ultimate control you only get if you run your own node, obviously, which is always an option, of course, in our space, which is pretty nice. Then, yeah, another thing, a project I love is Railgun for on-chain privacy. Anyone used Railgun before here in the room? Okay, cool. No one. Yeah, Railgun is like a privacy protocol. I think Ethereum Foundation also announced they want to integrate with them for their wallet SDK data building soon. And basically, it uses CK snarks to connect your wallet, and you can shield any ERC20 token, and then you get it as a private balance, and then you can transfer it in their system. You can even swap privately, and then you can unshield to another recipient. Yeah, and then if you use if you're a signer on a multisig, like I said, you should have some general things. Like there should be no single point of failure in the multisig. Like if one person is not available or one device is not available, the multisig should of course still be able to go through. There should be standard procedures for the team or like for the protocol that uses it. Nose safe is the most well known, I think. Even if there was like this incident with Bybit in the past. Every signer should use like a hardware wallet, and ideally the keys will be distributed geographically as well. See. And yeah, then the another important point: verify on device, not on screen. Said it before. The UI might be compromised, so you cannot trust that. Yeah, and then another thing which I really like is what I said before is you can use the multisig also for your personal usage. So that's what I use for my main wallet. I have a multisig, Gnosis Safe, or it's just called Safe now, I think. Multisig. Then I have two hardware wallets as a signer and one hot wallet, which is like kind of a backup. And so I always need two of these three wallets. So even if one key gets compromised for some reason, I still have like a safety because they need two to get my funds out of it. And then if one key gets compromised, I can replace it if I know about it. And yeah. So if you want, we can do some demo and hands-on. Like if anyone is interested, like never created a multi-sig on Gnosis, for example, we can do that right now, like together. Maybe hands up who would be interested in that. Yeah. Okay. Cool. Yeah, all you need is like your machine. You can do it on mainnet if you want. You can also do it on Sepolia on the testnet. There's a faucet which is sepoliafaucet.com. If you want to use that, you need, I think, use an address which has either mainnet. But yeah, so how to do that is, yeah. So the process would be going to app.safe.global, which is the website for Gnosis. Oops, it's the wrong browser. Go. Oh, yeah. Find a good way. Yeah, maybe like this. So if you go to app.safe.global, you will probably see at some point something like this. So here we see I already created a multisig, so you will not see that, but you will get prompted to create a new safe, which is similar to what I get when I say add. I know add is for an existing actually. See, insert it. Just. Yeah, let's add another network. Then yeah, you need connect your wallet, and then you can generate an address and add it here. Let me see if that works actually. Yeah. Okay, yeah, I think I cannot go through the process with this address because I already created one. Just do this. Okay. Yeah, go and create account. So this is what it looks like if you um, create a new multisig wallet. Then you select your networks, so you can create it on multiple networks at the same time. The benefit is they use to create 2 opcode to give you the same address on every network. So just call it the DSS demo, give it a name, and then you add signers. So you can start with only the address you created from as a signer, but you can directly add multiple signers as well. You just need to add the addresses here. You can give them alias names as well. Yeah, maybe let's copy this one. Give it like a second signer. Then you can say we want to have 2 out of 2 signers, for example, and go on. Then, yeah, you have to pay gas fee to create it, but you can by now in the UI also say pay later, which I do because I don't have ETH on that address. Yeah, and then basically you already have your multisig. You have your own address here, and you can see assets, and then you can also do transactions. So how you can use it, you can basically propose transactions directly from the UI, but if you want to use it for DeFi, that's obviously not super useful, but you have the little wallet connect icon here, so you can connect basically to any DeFi app via wallet connect. Maybe we can quickly try to do that. I'm going to Aave. Testnet. Yeah, if you say connect wallet, you usually have wallet connect at some point, and you just copy the link and go here. So now I'm connected to Aave with this multisig wallet, and I could like propose transactions like I would do with any other wallet, and then they pop up here, and then you have to sign them. So maybe let's just do this with like the other wallet where I have funds in. Uh, da, da, da. Yeah, this one. Yeah. Gotta hope the internet keeps stable. You know, the other days it was a little bit tricky. Yeah, so we have 0.01 ETH on this wallet. So I can just supply it to Aave, for example. If I do that, see on the other side in the multisig, there pops up the transaction, which is visualize. Okay, yeah. So what we see here, we have the transaction data as well. So after the Bybit hack, actually the Safe UI improved a bit, so they show a lot of things. So what you see here, for example, what was the case with Bybit, like the operation in Safe, like is the first of these parameters here after the data. And if it's set to 0, then it's a regular call. But what happened with Bybit was they were tricked into doing a delegate call, which was actually changing the Safe smart contract implementation address, which was something they should have spotted when verifying the data. So at this point, the transaction gets proposed, and then the first signer, in this case, can sign it, which is I have not verified the data, which is not good. So what we could do is take that data, or ideally, of course, if it's like a hardware wallet, the data from the hardware wallet, then we can decode it, and we see its deposit ETH and which address and which amount. Confirm it now. Sure. So now, because there's a 2 of 3 multisig, there's still needs another signer. So what I'm going to do is switch to the other wallet, and then we would have this screen where we see the data again. So the other signer also has to verify all the data, same way I just did it. And then what's also usually seen pretty good is like transaction simulation. So Gnosis is directly integrating with Tenderly here, so we can basically run a simulation and open up Tenderly to see exactly the simulation output, which is especially like if it's like a critical wallet, you should always simulate and also verify the simulation of the transaction. Going to confirm that here now. Not I'm going to say sign. And then any one of the signers can actually execute the transaction, paying gas and sending it on chain. And this is now an execute transaction from the safe. We want to decode that. We see its exact transaction, and then inside these bytes here, we also want to decode these to see, yeah, this is our deposit Eve function. And we see the first of these zeros here. This one is the operation parameter, which is like the regular call if it's a 0, or would be a 1 if it's like a delegate call. Gonna send that. Then eventually our transaction goes through. Yeah, testnet takes a while to getting that indexed. Anybody was able to create a multisig here, or something you want to do later? I think it's like a little bit hard with the timing right now. Hope that's fine. Okay. Yeah, let's talk about some other potential attack scenarios, which is interesting and which is just think people should be aware of. Like there's like things like DNS hijack or like code injection that can happen. For example, I think this happened to Curve before, Curve Finance, which is somebody was able to hijack a part of the domain and use this to inject JavaScript code into their front end. And this could be easy, like as easy as this, which is just overriding the Ethereum request, which starts the wallet, and changing the to parameter to an attacker address. And then the only way to verify this is to check in the actual wallet what is the actual to address in the transaction, because you would see in the app, okay, yeah, it goes to this address because the app thinks it's initiating the transaction to another address, but yeah, in reality, it's going to be sent somewhere else. And this is hard to catch because the website looks fine, even the SSL certificates and everything is good, but because it was in the underlying DNS where something was wrong, this couldn't be catched like if the regular certificates and HTTPS methods you would use. Another one pretty common right now is like malicious VS Code extensions. Like I think there's a famous Solidity VS Code extensions which has 50K installs, which extracts basically all your secrets you have locally. How this works, it does the actual thing the extension is doing, but it does, in addition to that, it's reading all your secrets from SSH or .env directory. So I think important here is even like a kind of social proof with 50K installs is not enough of a proof that it's like a secure application in that case. Yeah, so how to defend against this? Again, if you have like a signing device or like you work with secrets, it should be like a different device. Always check the actual transaction, ideally in the hardware wallet display. Yeah, and then, I mean, the last one is a little bit hard, DNS and certificate dependencies. You have to be aware that there's these attack vectors. I think if you're hosting like a website, you should check your dependencies on DNS providers and what you're using to make sure you're on the safe side there. Yeah, I think we can skip that. If you want, you can go to revoke.cash. I showed the website before. And check your wallet, see if you have any hanging token approvals, and ideally get rid of them. Yeah. Yeah, so if you see, like I showed before, like there's unknown contracts and especially unlimited approvals, you probably want to get rid of them and want to change it to only have the approvals while you actually use the protocol and you need these set up there. Yeah, then another thing about QubesOS, like I think I already talked about it multiple times. Can do like some more advanced like device isolation. I wanted to do a demo, but it was hard with the hardware I have here. It was hard to set up the QubesOS. I have it at home, but yeah, unfortunately didn't make it to show it here in the demo. But if you want to try it, it's a cool project. You basically install it, you have an hypervisor, and every task you want to start, it creates another VM for you. It's fully isolated on the OS level. So even if you have like a malware on your browsing device, like your daily browsing device, it will never affect anything on the VMs you use for wallet operations or for development even or whatever. I mean, yeah, the other alternative is if you just want something to sign crypto transactions securely, just get a cheap $200 laptop, install TailsOS or something on it. It can be even any Linux distro. Tails is like a little bit more tailored to private security. But yeah, just get a separate device and do your signing and crypto operations via this. And don't use your daily driver for crypto operations. Yeah, the sprint was actually already to wrap up. I guess key takeaways, there's always multiple layers in terms of operational security and security in general. And it's not enough to have only one layer, but we need all layers. Because after all, security is not like we can fully protect against something, but it's just trying to make it harder to get exploited. With every layer we add, it's getting harder and harder for attackers to exploit us. Then verify everything, don't trust. Use always official sources. That's for getting software, also for getting hardware, especially like hardware wallets, of course. Never get like used ones. Always go to the vendor directly and get your hardware there. Yeah, try to minimize like a attack surface. Like if you don't have like a lot of exposure outside, you're a less public person. And obviously that's not always possible, but if you're less public, then you're a smaller target and have like a smaller attack surface after all. Regular audits, like we do of course recommend regular audits for code, but also regularly audit your own OpSec. What are you doing, how you're achieving things, and maybe even make a checklist to what you want to do regularly and stuff. Yeah, and stay current, like keep your devices up to date, but also keep your knowledge about what's going on in the space up to date. And yeah, maybe there's new attack vectors coming up every day, whatever, and you should be aware. Yeah, like I said, if you want, you can commit to up your OpSec and create your personal action plan. Like maybe there's a tool like DangerZone you want to do. You want to set up a multisig. You want to audit your token approvals. Maybe there's like a habit you have, like browsing and mixing browsing and crypto on the same device. You want to change. Yeah, feel free to set up a plan. And if you want, you can tag me on Twitter and send me your action plan to have like some responsibility there. Okay, so now if you guys want, we can have a closing poll. Would be great to see Now, after this workshop, how do you feel about it? Yeah. How do you feel about your OpSec now after the workshop, basically? Let me get that up. Perfect. Cool. Yeah, looks great. I hope you learned something. If you want, stay connected. Follow me on Twitter. I'm at @dshogoki on Twitter. And yeah, let's add some final thoughts. Yeah, good quote. The best time to improve your OpSec was obviously yesterday. The second best time is today. So you should get started. You should be aware. You should know some tools. There's always new tools coming up, though. Get an action plan and just start improving your game, I guess. So thank you. I hope you could learn something. And yeah, if there's any questions, I'm here for another 15 minutes almost. And then we can all go to lunch.